average rate of change is something you probably know a little bit better as slope. Back in Algebra 1, you learned about something called slope-intercept form of an equation of a line. In this equation, y equals mx plus b, m was the slope of the line, told you if the line went up or down from left to right. B was the y-intercept. You also learned how to find the slope of a line given 2 points. So if you were given 2 ordered pairs, we'll call the first one x1, y1, and the second ordered pair that lies on the same line, x2, y2, you could find the slope of the line by doing y2 minus y1 over x2 minus x1. You might have also called it rise over run. So average rate of change is actually just a slope of a line between 2 points. And it tells you how fast a quantity changes over time. You know, in the real world, you're not going to be finding the slope of a line, going, oh, here's 2 points, go find the slope of the line. That's not how it works. You might, however, be analyzing a graph or a table of data, and you may be looking for how fast a quantity changes over time, in which case you would be finding the slope of a line. Now, you may have only found slopes of lines that were linear. When we actually do average rate of change, a lot of times the graph is not necessarily linear. But the line that connects 2 points of which you're trying to find the average rate of change will be linear. So in this graph, I want to find the average rate of change between this point and this point. So the first thing I would do is determine what the ordered pairs are for those points. The one on the left is at -1, 0, and the one on the right is at 5, 4. So if I call this x1, y1, and I call this x2, y2, then I can find the slope, or the average rate of change, by doing y2 minus y1 over x2 minus x1. Watch out for those double negatives when you're doing the slope formula. So you get 4 over, this becomes a plus, 6, which reduces to 2/3. And then always ask yourself, does that answer make sense? Notice the dashed black line between them that I've now made blue. That line is going up from left to right. That means that the answer we get should be positive. Because we learned in Algebra 1, there are 4 types of slope. A line that goes up from left to right has positive slope. If it goes down from left to right, it had negative slope. If it was a horizontal line, in other words, it was a constant function, it had 0 slope. And if it were vertical, we said the slope was undefined, or maybe your teacher said the line had no slope. Either one of those answers works. Another way we have for finding average rates of change is if we give you an equation and then we tell you the x values between which we want to find the slope. This here, this is just y, so it's y equals 3x minus 2. And we're going to talk about number 9 here. In order to find the average rate of change between those 2 points, it'd be nice if I knew the whole ordered pair. I know there are 2 ordered pairs. One of them has 2 as the x-coordinate, and one of them has 3 as the x-coordinate. What I need to find is, well, what's y? You find y by plugging the x value in for x into the equation. So we're going to find 3 times 2 minus 2, and that's going to tell us y. 6 minus 2 is 4. So the first order pair is actually 2 comma 4. And then the second order pair, we're going to plug 3 in for x. 3 times 3 minus 2. 9 minus 2 is 7. So now I have my 2 ordered pairs, x1, y1, x2, y2. And we're going to plug it into the slope formula to find the average rate of change. y2 minus y1 over x2 minus x1. 3 over 1 equals 3. Now you may be looking at this going, well, I knew that this was mx plus b. And so I already knew the slope was 3, and that's true. In this particular problem, we could have looked at the equation to determine the slope. But remember, not all equations are linear. Sometimes they're quadratic or cubic or absolute value or square root function. So you can't always know the slope from the equation. Sometimes we want to find, sometimes we want to find the slope between 2 points on a graph that represents a real situation. So in this particular problem, it says the graph shows the population P in a small industrial city from 1950 to 2000. The variable x represents the number of years since 1950. So what you'll notice is on the graph, the x-coordinate is years. But the years are not what's listed on the x-axis. They just say 10, 20, 30, 40, 50. That's because 0 is 1950. So this is 1960, 1970. Oops, that looks terrible. Make that look nicer. 1970, 1980, 1990, and 2000 is 50. It's just using 10, 20, 30, 40, 50 simplifies the problem a little. Notice the y-axis is the population in thousands. So the population of this city is not 50, it's 50,000. All right, so we want to find in part A what the average rate of changes between x is 20 and x is 40. So when x is 20, here's my point. The ordered pair is at 20, 40. And when x is 40, I go up to the point, here it is. It's the ordered pair 40, 40. So the average rate of change is going to be y2 minus y1 over x2 minus x1. 0 over 20 is 0. So that's saying that there was no change in population between 1970 and 1990. So in part B, it says, interpret the value of the average rate of change that you found in part A. So those 2 points that we were finding the change between, if you connect them, you'll notice that the line is horizontal. Well, what's the slope of a horizontal line? It's 0, because the slope kind of tells you how inclined the line is. Well, there's no incline. It doesn't go up, it doesn't go down, it stays the same. So even though you can see on the graph that clearly the population goes up and then back down, if all I do is look between 1970 and 1990, which is x is 20 and x is 40, there was no change in the number of people per year. We can also find average rate of change by using information from a table. So in this particular problem, it says the table gives the population in a small coastal community for the period of 1997 to 2006. Figures shown are for January 1st in each year. What was the average rate of change of the population between 1998 and 2001? So in this table, in general, x is years. In physics, you probably always put time on the x-axis of your graphs. A year is a measure of time. So our input is the year and our output is the population. So this table is written in ordered pairs. So we want to find the average rate of change between 1998, 856 and 2001, 1597. So my average rate of change is going to be y2 minus y1 over x2 minus x1. So the numerator is 735 and the denominator is 3. And 735 divided by 3 is 245. Now what does that answer represent? It's great if you can get the answer, that numerical part of the answer. The hard part is giving me the units of measurement. So what's happening is the average rate of change is that the population in this town is changing 245 people per year. All right, let's try this again. In part B, What's the average rate of change between 2002 and 2004? So same thing. I'm going to call the first ordered pair x1, y1, the second one x2, y2. So the slope, or average rate of change, is going to be 826 minus 1483 over 2004 minus 2002. You can probably tell right away you're going to get a negative answer. In Part A, from 1998 to 2001, you can clearly see that the numbers were going up. That means you should get a positive answer for your average rate of change. But from 2002 to 2004, the population's going down. So I expect to get a negative. So the numerator is going to give me negative 657. The denominator is going to get 2. Negative 657 divided by 2 is negative 328.5. And again, that is people per year. So in this case, the population is going down, 328.5 people per year. Part C, for what time period was the population increasing? All right, so going back to my table, I want you to notice that from 1997 until 2001, the population was increasing. When we did intervals of increasing and decreasing, the intervals of increasing and decreasing are always the x values. Well, the question said for what period of time? It was asking for the x values. So it was increasing from 1997 to 2001. In Part D, for what period of time was the population decreasing? What we're going to do is we're going to start from the highest value, which was in 2001, and then watch how long it goes down for. So the interval of decreasing was from 2001 to 2006. This covers all the different ways of finding average rate of change that you'll see on the first assessment.